more data can be opened, the better. I think there's going to be a huge amount of capability that we gain from large, powerful companies releasing more of the data that they collect by making your data available to other people who are going to have a different lens, you're going to have different techniques, a different goal in mind to analyze your data and try to make sense of it for solving a different problem. That's where some of those interesting collisions between two people who are looking at the world very differently. That's where we're going to see some really interesting solutions come out that we otherwise wouldn't have found. Why focus on data and open data and making data more accessible? It's not sexy. It doesn't have the same kind of draw of like building. Like AI is definitely the hotness right now, and it's the thing that everyone wants to talk about their AI algorithms, and I'm not dismissive of that at all. I think it's amazing, and I'm very very interested in all of that work. But it's also, I think, well known among people who are actively doing AI work that the quality of the output of AI work is very tightly correlated to the quality of the input data. And there's a lot of the work that data scientists and AI researchers, and particularly people doing machine learning work, a lot of their work is spent in cleaning the data and preparing it. And when you have data that is that has been pre-understood, that has that like semantically linked data that actually has the knowledge about what the data means embedded within the data, is going to yield better results faster than searching through unstructured data that does not have any of that meaning embedded. But it kind of crosses the spectrum, right? Because a lot of times what you have to start with is the least structured stuff in the world, right? It's text, it's things that were put out there for human consumption, and it's not just that it's not structured for machine, for machine use, but it's written by people, and every single person writes differently, and there's misspellings, and there's grammatical mistakes, and there's cultural differences, and there's so you're starting from the messiest possible data, and machines can help. But we're getting better at using machines to extract labeled structured data out of that. The trend, I think, that hasn't really happened yet, but I think that is starting to, is once you've done that work, capturing and reusing and iteratively getting better at the level of the data. I think we iteratively make our algorithms better and better for how do I go back to messy data and make it better. What we don't do is kind of curate the data assets themselves and make them iteratively smarter and better, so that the next iteration of building on that data has a better place to start from. I think that's something we're starting to see happen. I got really interested in the problem of how do we better connect data and how do we have more data assets that are of high quality to do some of this learning research. It's an area that hasn't really been focused on, and there hasn't been enough investment here. There was an opportunity to go kind of really help make a difference and move this part of the equation forward, and a big part of my motivation was there's a really great technology that's kind of custom built for this. I think the semantic web technology, this is the vision of the next iteration of the web that's put forth by folks like Tim Berners-Lee, who was the inventor of the original web and has been an advocate for the continuing development of the web as a resource for humanity. And he has been, the guy pushing for, if you go back to his TED Talk in 2009, kind of reaching out about trying to get people to embrace this linked data, he brings up a couple of things. He talks about the network effect, and I'm here talking at TED because this is the sort of thing that it would be really great if everyone just did it because it was the right thing to do, because we're going to have to get over that hump. And I think that was part of what he reached out there. He talks a lot about raw data now. Publish your raw data. Don't worry so much about how we've got to get to this linked data world. Don't worry about how that happens. Just get your data out there, and iteratively over time, this is going to be kind of an inevitable movement. And And then, the big conclusion he has there is, the web that we have today, it's nothing compared to the web we'll have when we actually achieve this linked data vision. This technology stack is for this purpose. It's there to make the web the most valuable resource it can be. That includes how it interacts with AI. It includes how AI can contribute that flywheel, and ultimately how it becomes the most valuable resource to solve problems for humanity. That's what really drove me into this space is that AI is going to get better and have more resources to work with and have a better thing to contribute back to, the more that we have this infrastructure around the data that artificial intelligence can use to do its work. What is data means different things to different people, right? To many lay people, they're not thinking in terms of structured data really at all. Data is text. It's words you read that convey information, or it's images, or it's videos, and all that certainly is data. I think when you start thinking about more structured types of data, where you've got large tabular types, statistical data sets, where you've got rows and columns and relationships between entities and numerical or categorical information about them. That's another kind of data, and that's really, I think, mostly where when you start talking about data science and analytics, that's where people's head goes. And then if you think just a bit beyond that to semantic data, which is really just semantic data, linked data is really just a universal format for representing that structured data, where all the information is broken down into statements of the form subject, predicate, object, right? There's an entity, it exists in some relation to some other entity or some value. And by breaking data down to that very, very, very simple format, you now have a format where you can take all of that tabular structured data and you can represent it in a common way. You can talk about the data in terms of the actual factual statements that the data is making, as opposed to being confined into that file, that structure that it was used to move around collections of data. When I think of unstructured data, that's where I think of human text. Natural language text and images and videos and sound and the sorts of things that people have a very easy time interpreting with our brains, but the computers we make lots of little topical successes in computers being able to understand natural language. But what does understand really mean, right? I think it's still pretty unarguably true in 2017 that computers don't understand natural language exactly the same way that you and I do. They're making great strides in solving pieces of that problem, and I think that trend's going to continue. But that all of that natural language, that visual, that audio data, that working with that in an analytical fashion generally involves extracting some meaningful metadata, extracting some model of understanding what that data is about. And that's actually the thing where, that's where, to me, that's where the state of what AI is really good at and how that relates very much to semantic web and to thinking about, modeling knowledge graphs. That's where the sweet spot of AI and knowledge management really is today. We have software that's quite good at looking at a piece of human readable text and telling you what real world entities it's about, and a model that a person can understand, and more importantly, that another computer can understand, of what are the things that are being said about those entities. If I can read a piece of text and said, a computer can read a piece of text and give you a structured analysis of that text that says, this text is about the President of the United States, and it says that he made a statement about this event that took place in Europe. I think that kind of structured data can be extracted out of that human readable text. What that allows, how that folds into thinking about all data as being connected is now you can take large volumes of this human readable text, you can turn it into a structured analysis of the kinds of things that are being said and the kinds of real world entities that are being discussed. And you can compare that analytically. You can analyze. We're good at analyzing Twitter streams to understand trends of things that are happening in the world by doing this kind of analysis. You can start to correlate that data with the more statistical tabular information, and create new types of insights. And that to me is the inevitable direction that the network effect of linked data is going to have, is that all of this data in the world, all this tabular structured analytical data, all of this data that was really meant for human consumption, we're going to increasingly get better at capturing the essence of the facts that are being asserted about the world into a common format where all that information is just information and it's all equivalently accessible. So you can have computer programs that don't really care whether somebody put together a structured database of things the president said over the last 3 months, or whether those things were just said and reported on and published through some natural language. All that information is going to be equivalently accessible through a coherent knowledge graph. There's a lot more investment today in the kinds of machine analytics that are good at extracting this information and turning it into machine processable formats. And that research is happening largely because the computing power is getting more, the cost of that is really driving quickly toward zero. We're kind of entering the world. The phrase I heard used for this recently is infinite computing, right? It's not necessarily, it's wrong to think of it as free. It's right to think of it as driving to be so close to zero that you won't think about the cost of computing resources any more than you think about the cost of plugging an appliance into the wall and using electricity, right? It's not free, but it's not the driving cost. It's not the thing that makes So as computing becomes less the barrier, we can do more things that historically would have been considered brute force type approaches. And intractable because they were too expensive to compute, and those kind of arguments start to become irrelevant when a student at a university can, for a really low cost, go spin up dozens or hundreds of high CPU machines on a cloud computing provider and run through CPU months of computation in a matter of hours at a cost that just a decade ago would have been prohibitive for large corporations to do. Our platform is a social network for people working with data, and what that means is that the tools that we provide within the platform are about sharing data and collaborating on data work. So people working on our platform are generally using two key assets. One would be a data set, which would be a collection of data. One would be a data project, which would be kind of an ongoing analysis or body of work. Those two things are kind of fungible to some degree as well, right? A lot of times the output of a data project is a new data set, and then the data projects get used as sources, the data sets get used as sources in data projects. But there are a lot of tools for solving some of these problems. What those tools have not really previously done is focus on the collaborative nature of the work. So there's a lot of money invested in analytics tools and visualization tools and reporting tools, even in knowledge management tools, but they're not focused around connecting all of the people with different personas who are working with data. We're building a data collaboration platform. It's two pieces to that. We are using a lot of the semantic web technology, which is really about linking data and applying the architecture of the web as it is today to data elements. And we think that the best way to build that resource and to increase the amount of linked data is to link the people who are working with data. in the world right now today, it's people working with data that are adding context and knowledge and real meaning to the data they're working with. And we think that's by building the social network for people working with data and giving them the tools that as they work with data, let them connect to the data using that semantic web technology, we can accelerate the amount of connected data there is, and that's going to play into a flywheel with machine learning and with AI being applied to the problem of better connecting our data. It's a flywheel in many ways, right? The better connected your data is, the more semantics and meaning you have about the world's data, the better machines can employ that data to solve problems. And by getting more signal about how that data is connected from people working with data today, we can help accelerate machines in becoming part of that process on the producer side as well. Our angle on trying to accelerate that movement is, let's build a social network. Let's connect the people who are doing real data work today, and the work that they're doing is knowledge engineering. It is ontology related work where they are basically taking data, understanding the meaning of it, but that work is being done in project oriented siloed fashions where you gather the data that you need, you make sense of it for the purpose of your one current project, and then that knowledge about what the data means gets lost. What we want to do is let people work with data the way they're accustomed to. If your data's in CSVs and Excel spreadsheets and relational databases, that's fine. Bring that to our platform, work with it like that. But as you work with your data, we turn it into an RDF model of that data, and we start to iteratively build up that ontology and that structured semantic knowledge about the data so that the next person who comes along doesn't have to recreate that same knowledge work. Semantic web is a very mature technology at this point. It's been around for a long time. It's been pushed by the same people who kind of invented, architected, and popularized the web itself. But it hasn't really cracked into the mainstream. It's well studied in academia. It's well employed in financial services, in pharmaceuticals, in certain industries that have a lot of need for these data collaboration and for really embedding the meaning of data within data. It hasn't really cracked the mainstream. There's a learning curve from the way people are accustomed to working with data to this technology, to using this technology, and not a lot of firms have really kind of taken on that learning curve and kind of cross. But it's like any network effect technology. When a network is small, the benefit to joining it is relatively small, and so the cost benefit doesn't really work out. But as the network gets larger, the value grows exponentially, and at some point you wouldn't dream of today in 2017 publishing information for human consumption, other than putting it in HTML on the web served via HTTP. Like that's the architecture that humans use to share information meant for other humans. We haven't really gotten there with data. Data doesn't have that same kind of universal standard where all the data is interoperable. But that standard exists. It's the RDF RDF technologies, semantic web technologies, and a lot of firms are using it in siloed fashions to build their large internal graphs. What hasn't happened is really democratizing that technology to the point where everyone can use it. We organize the company as a public benefit corporation, and our public benefit statement is specifically around increasing the amount of open and specifically linked open data in the world. And we're very committed to that cause, but maybe a little paradoxically, I think something we thought was really important in order to achieve that was to embrace the idea of private data, of being able to work on data in private. A couple of reasons for that. One is just there's some data that makes sense to be private, right? There is some data sets that you collect as an organization that are competitive advantage versus in a business context might be competitive advantage, or that have some sensitivity for people's identities or for privacy concerns. So there's some data that makes sense to be private, and there always will be. But even data that ends up being open has a life cycle during which it might make sense for that data to be private, right? When you're working on building a data asset, you don't necessarily want to do all of that work 100% in the open. You might want to do that work in private and develop it and work with peers, and you might have a slowly growing concentric circle of people that you expose that work to as it gets developed. If you're an academic researcher, you certainly want to be able to be the first person to publish papers and results of that data, and then over time making the core data assets themselves because open becomes something that that movement is happening in academia. I think it seems maybe a bit slower than a lot of us would like at times, but the movement toward actually mandating that when you publish scientific research, you publish the data in a meaningful, usable, and really in the modern age that means machine readable and fully repeatable way. That movement's happening. It's happening slowly, and I think it is more of a political. Maybe political is the wrong word. More of a more of a mindset shift than it is a technology. But it's also that there hasn't really been a lot of great technology focused on that sharing and making data open. Think about academics who have data assets that they should make open. You think about corporations who have these really valuable data assets that could actually do a lot of good in the world. They perceive there to be risks, both legal liability risks, business risks to opening up that data, and the benefits to them aren't always clear, and there's a cost associated with solving some technological problem in order to make it open. It's all cost and risk with no upside. There's just not a lot of incentive for people to make their data open. I think the thing that's changing there is very similar to what happened in the open source software movement. If you flash back 20 or 30 years, every company used commercial solutions and built their own everything else. And open source was kind of a fringe movement that really wasn't seen as something that was tightly coupled with the business community. Now, tons of billion-dollar companies have been built on producing open source software. Every company, every internet company, every technology company uses some amount of open source technology, and the benefit there really is that every company, every organization doesn't have to resolve the same problems, right? There's a lot of technology solutions that are just commoditized, and that's really what open source technology is for, is let's solve this problem once, let's develop standard solutions. Everyone can use those solutions and contribute back improvements. I think the same exact thing is going to happen in open data. And I think that's the part of the movement we want to be part of. And I think if you look at a platform like GitHub, which has really been accelerative to the open source movement, GitHub likely was the cause in many ways of there being that much open source there. They were the platform that really kind of made it easy and obvious for people to make their data open. And they are also the leading place for people to develop their corporate private IP in private. And I think it's that permeable boundary that is actually part of what's powerful there. I know a lot of companies firsthand who didn't have a lot of interest in doing anything in the open source world, but who used GitHub as the tool for developing their private IP because it was what their engineers demanded. And then over time, because it was so easy to say, this project that we've already been developing for our internal use really isn't a competitive advantage, and we would actually benefit from opening this up, letting other people use this technology and contribute to the development of this, and contribute back changes and bug fixes and improve this technology. And when it's as easy as going in and clicking a button to say publish this and make it open, that's a much easier conversation than we'd like to open up this software, or in our case, this data set. Okay, what's our first step? And that first step is an expensive, technology acquisition process or development process.
Is there anything in particular that you'd like to find in the world's open data?
I mean, I think, it's easy to kind of start going everything, right? I think it's easy. The answer is, it's kind of like, yeah, but the thing I think that that's the most interesting about what we'll find as we get better at making our data more interoperable and thinking about how data that's about the same things in the real world needs to, we need to be able to understand that in a way that both machines and people can easily make those connections, is that the kinds of thinking that we're going to need to solve kind of the biggest, hairiest problems, big medical problems. How are we going to ultimately cure cancer, or, geopolitical problems, the problems of, how to understand what's happening in the world when these, hugely complex, multivariate types of things that are just, they're intractable for people to even think about. I think what we're going to find is a lot of the solutions are there, but we don't have people, they're not going to be solved by people in one discipline looking at one type of data through one lens. They're going to be solved in a multidisciplinary fashion, where people who are, two people who don't realize that their work actually could be combined in an interesting way to produce a new insight. That's, I think, the kinds of, serendipitous collisions we're going to see happen as we make data smarter and smarter.
Do you think everybody has to become more of a data scientist in a sense to remain competitive?
Yeah, I think the answer is, the answer is it's complicated because, I'm tempted to say the answer is no, but I think, there's I think everybody is naturally going to become more data savvy, or I think, the average data savviness of people is going to increase. But that doesn't mean that everyone's going to become, a professional statistician, a professional data scientist the way it's formulated today. I think, again, I think there's a model for this, which is the web. If you flash back to the late 90s, the people using the web were mostly, kind of hardcore technologists. Flash back a little bit earlier than that. The first people using the web were, scientists at CERN and the people that they were reaching out to collaborate with. It was a lot of effort to be part of that community. And it was really the diehards who cared deeply about it, who, if you flash, you talk about the late 90s, early 2000s, if you wanted to put up a web page, you basically, the way you did that was you hand authored HTML, and you really had to, know something about the HTTP protocol and the kinds of technology that was involved in being a webmaster and posting the data. You keep flash forward, you've platforms, to me it seems like one of the first was, maybe Blogger coming out of Google, where this was a platform where, you can just focus on your content, right? You write your text and it's published on the web, and you don't think too much about the technology that's empowering it. It's all still there. It's all, like today it would be Medium, right? And it's so easy to go onto Medium and create a new post and type a few lines of text and hit publish, and it's in the world. And it's, we don't think of that as being we don't think of people who are capable of doing that, or, even simpler than that, making a Facebook post. You are publishing HTML on the web using all the standard web architecture, all the reasons why the web was designed to scale up infinitely and horizontally. Now everybody can use it from their mobile phone to not just read the web, but to write to it. We don't think of those people as technologists. You don't think of, teenagers writing tweets and writing Facebook posts, or people writing Medium posts as technologists, but they're leveraging a really powerful technology stack. I think we're going to see a lot of the same thing start to happen with data. That information is going to be turned into these standardized machine readable formats, analytic friendly formats, through tools that are not going to require people to level up their technology. I look at our, the people who use our platform, and a lot of them are really, they're quite comfortable with an Excel spreadsheet, and that's kind of that's kind of where they're at, and we embrace that. I think that's it's a great technology. It's a good way for people to look at tabular data and kind of understand the shape of data. But if I can take that same data and put it into a format where now I can identify the entities in that data and say, well, actually, this person has a spreadsheet, and that column has 5-digit numbers, and those 5-digit numbers, those actually are zip codes, and a zip code is a real world entity. And over here I've got the U.S. Census data, and I've got that broken down by zip code tabulation data. Now I can start to do interesting things with, this person's spreadsheet that they've collected. They've broken data down, by a zip code, which is a rough geographic approximation. I can now go take some, demographic information and correlate that. And I guess I definitely don't think that we're going to help build, the web of linked data by converting every data user into a semantic web and RDF expert. I think, just like HTML and HTTP are kind of the core technologies that empowered the web that is so ubiquitous today, I think the semantic web technology stack, RDF, Sparkle, which is the query language over RDF data, those are the core building blocks. And when the semantic web is as ubiquitous as the web of documents is today, those are still going to be the building blocks. Most people won't ever look at them or really understand that that's what's going on behind the scenes, and I think that's fine and natural.
It seems to me like some of these technologies seem so complex and incomprehensible, while in the long run they make everything much, much easier for users.
Yeah.
Do you have some thoughts on how this transition period could be made maybe less confusing?
Yeah, no, I do, and I think, again, I think it's, drawing the same analogy. Drawing the same analogy, I think, HTML and HTTP, are technologies that most people would be, sitting down to read the HTTP specification would be something that most people's eyes would glaze over, and they'd have no idea what they're looking at. But it makes the world a lot simpler because that piece of technology, the fact that it exists, means that Amazon and Google and like all the other things that people consume on the web, it's the way those things work, and so I think in terms of using data to make people's lives simpler, I think these are the kind of the technologies that take that can be leveraged to take this daunting amount of personal data, right? You generate a lot of data in a day about your activity. You don't have a meaningful way of really processing that data and deriving insights from it. You just taking that raw data as a human being, it's too much, right? It goes back to where do we need machines to assist? Well, we need machines to assist taking that raw data and contextualizing it and breaking it down to a piece that you can actually consume and you can actually work through in a reasonable amount of time.
Do you think understanding all the details about what's going on with our data is even possible?
You can't. It's too big. Like there's too much of it. If you just taking like a simple example, right? Like what you talked about, thinking about quantified self type. People, a lot of people are wearing fitness trackers. That fitness tracker, what it's doing is sampling a bunch of metrics about what's going on in your body at some period and recording those individual observations. But what you're consuming as a person is a derived set of insights that have been computed for you. Is that artificial intelligence? It's something, right? It's some, you aren't being presented with the daunting, list of numbers that are really that's the actual truth of what's being collected by your Fitbit. It's sampling a set of numbers over some period, and there's a huge time series of data that's looking at you every day, that's looking at you compared to previous days of yourself. It's looking at you potentially compared to other people and benchmarking you against, standard norms of data. There's a lot of intelligence that's been hand coded by people and maybe has been, developed with machine learning techniques. But that's a simple example of AI taking a daunting set of numbers that wouldn't make a lot of sense for a human to try to wade through, and turning it into a bite size. You should go to sleep now, or you need to get up and exercise more because you haven't done enough exercise today, or translate that to looking at your web activity. You mentioned from the Everyone Lies book, people, what they answer in surveys and their actual activity are often pretty far apart. I'd wager, I guess, and this is just pure speculation, I'm not, that most of those people they're not lying in a meaningful sense. They have no intent to lie. They're actually lying to themselves equivalently, right? People, they probably think they're answering those surveys truthfully based on, who they think they are. And that data can really help people shine a light on what your actions actually probably determine your actual beliefs and what you actually are better than your picture of yourself. All of that it's a huge amount of data, and contextualizing it and figuring out how do those what's the right way to take all the web searches I've done and turn that into a cohesive picture of who am I? What do I actually like? The organizations that are leading the charge here are companies that want to sell you things, and they're extremely good at watching your behavior online and understanding, based on the things you've done, if I put this advertisement in front of you, I'm statistically likely to result in enough sales to make this a profitable way to profile you. So, we in limited domains, at least, we're actually pretty good at this predicting who you are. If you narrow who you are in that context to who are you as a consumer, what are you likely to buy? How can I predict the activities you're going to take based on past actions you've taken?
Where is all this data and all this insight about ourselves and our behavior leading us?
Yeah, it's been a trend, certainly in business, and certainly in the technology business, to get better and smarter at making data-driven decisions. Right? This is a lot of the driver for data science as a practice is that companies have realized that kind of a historical way of doing business was often the person with the loudest voice or the biggest title made a decision based on their opinion, and that's how business decisions got made. And most of the best business decisions get made when you have more data. And web companies have taken this to a deep extreme where if you're kind of doing best practice product development for internet web-based technologies, you're constantly trying multiple variations of every single feature that you release, down to what color is the button and what's the exact text I put next to a button that maximizes the probability that the humans using this product are able to understand what they should do next and take that next action. We've gotten very good at the science of data-driven decision making. I think in an almost untapped potential there that's going to be a huge thing in the next decade is putting that capability for data-driven decision making at down to the personal level. It goes to what you mentioned around if I have all this fitness data. One of the things I'm going to have to, one of the things we're going to have to face is at some point it's going to tell me things I don't like, that I don't recognize about myself. That fitness data is going to tell me, hey, you think you're a pretty active person, but you really, you've fallen down this week. It's time for you to step up and exercise more. It's going to tell you that you think you're eating well, but in fact, you've indulged yourself in a slice of chocolate cake a few too many times in the last month, and it's starting to show up on your waistline. It's going to tell you that you think you're a pretty politically progressive guy, but it turns out that your actual beliefs and your actual actions don't really jive with that. yeah, I think this is all good. I think we'll figure out how to do this in a positive way. But people don't always like to hear the hard truths, and a lot of people avoid getting medical diagnoses they don't want because as long as they don't know it, it's not they don't have to face it. So I definitely think there's psychological element. I mean, part of where AI is, we start to dismiss technology as AI once we fully understand it, but also, a lot of the AI technology you talked about, technology kind of disappearing and folding into the table. A lot of technology has kind of started to disappear and fold into us. And if you think about, I just saw in my email inbox. It was just a marketing email from a company that does an AI-based email assistant. There's a few of these companies out there, and just the headline of the title was "We are all already cyborgs," and I mean I think it is interesting to think about the fact that when you have a smartphone in your pocket with Google and Wikipedia and your Siri or Alexa voice assistant and access to all the world's information, access to contextualized information in the form of maps and a compass and a GPS, you have fundamental capabilities that people 30 years ago didn't have, right? Take the exact same, the exact same person genetically, the exact same, you are capable of things that human beings were fundamentally not capable of 30 years ago, as that curve isn't going to slow down, it's going to continue to increase, there's a lot of good in that. There's a lot of potential for solving a lot of problems. There's also a lot of risk in that, right? If that, as that technology curve continues, if you have different different vectors on which you have haves and have-nots, and if those gaps widen, not just in economic terms, which is already a thing that is a major problem for the world to deal with, but now in terms of this technology changes the people who have access to it and makes them something different. I think. I don't know.
Something better.
Something with more capabilities. Is it better? I don't know. I mean, I think it's it's an interesting thing to ponder, because to a certain and to a certain degree, some of the march of that progress is inevitable. If it's possible to continue adding those capabilities and those enhancements, it's going to continue happening. I mean, is it better? In a certain sense, definitely yes. In a certain sense, having more access to more information by more people is a good thing. But I think some of the things we're seeing now are the result of these capabilities increasing faster than really our societal constructs are able to keep up and comprehend it. I think one way that plays out is a lot of our legal systems don't have good constructs for dealing with the newer technologies. They don't have the laws can kind of lag behind the reality with respect to you see with ISPs and content providers, and the regulations set up for governing radio and then television have been slightly modified and iteratively improved upon to deal with the internet and the web, and the web as it's become a ubiquitous mobile platform that everyone carries in their pocket and has access to all the time, and it just the same. I don't think those same frameworks really make sense. But we don't really have I don't think we have enough focus on how do we actually address that.
Let's say the semantic web takes off and we have a lot more linked open data.
Yeah.
What kind of world would we
Sure.
live in then?
Yeah, I mean, we have, we have it to a small degree now, right? If you look at, if as you use a platform like Google's knowledge graph is a version of this. If you've used Google kind of over the arc of their existence, as from the early days, you know it used to be that you'd search and you get a flat list of links, and a lot of their innovation has been in making that list of links better and more relevant, and surfacing content closer to the top based on what you want. And that you've seen innovations where what you type in the box could have different meanings, but it knows enough about you to you get a different set of search results than I would based on previous things you've done or based on geographically where you are. Now you start to see that you don't always just get search results in the form of here's a link to a document, but you actually get factual information. A lot of times it's pulled from a source like Wikipedia, and Wikipedia publishes the structured data about the knowledge in their encyclopedia as linked data that can be pulled off and indexed into a knowledge graph. So you have a little bit of this now. If you go to Google and ask it, who's the president of the United States, you're not just going to get a list of links to documents that answer that, but you're going to get, the president of the United States is Donald Trump, and it's going to have, a photograph of him pulled from Wikipedia, and it's going to have information about who he is, and that knowledge is kind of pulled front and center. Start to, now go into your house and you've got your Amazon Echo and you ask Alexa for information, and that can understand your voice and parse that off into a sentence and go consult a knowledge base, and those answers are going to get better and better and smarter. And right now today, those voice assistants, they can do some interesting things. I don't think anyone would mistake them for anything close to an AGI, but there's a set of there's information that it can retrieve for you based on its understanding of what you want to know, and there are actions it can take for you based on commands that it's been trained to take. Those are going to get better, and they're not going to get better linearly. They're going to get better exponentially. They're going to increase. An analogy I like to use sometimes is if you think back to like Star Trek: The Next Generation and the shipboard computer, when Picard can just say computer, and the computer makes a little audible tone, and he can ask it any question or tell it to do anything, and it understands him perfectly every time and always delivers exactly the right information and always takes exactly the right action. There's a curve between what you've got with your voice assistant on your phone or your Echo and what that shipboard computer can do, and the gap is mostly going to be in terms of around the richness of the connected database of information that the computer has access to. How much information does it have to contextualize the thing that you're asking, to consult a knowledge base of information, and to give you back the answer that matches with what you wanted. I don't think we have a lot better to get in terms of hearing a human voice and turning it into a series of words. That technology is pretty good right now. Understanding what you mean by your question, we're okay, and we're getting better. And by the way, every time somebody opens up one of those voice assistants, you not only just tried to answer a question, but you also created a richer training set to continue learning what was asked and whether you got what you wanted when you asked it.
Is there something that you hope would change in the way people view or work with data?
Yeah, the more data that can be made available, that is made available for anyone to consume, the more everyone is empowered. The more everyone is empowered. It doesn't mean that everyone is going to become a data scientist and go do heavy duty analysis, but it means that the data is there for anyone who wants to. Anyone who wants to, second guess the result, second guess the analysis that somebody has fed them and say, well, I would like to go look at the raw data and draw that conclusion for myself. And I think there's going to be a huge amount of capability that we gain from companies, large, powerful companies releasing more of the data that they collect. They have financial incentives to collect data, and some of that data is their competitive secret sauce that they're never going to release. But a lot of that data is actually things that could be used to solve real world problems beyond kind of the profit motive. And I think that's kind of the flywheel. That's the corollary to the open source software movement that we will see, the open data movement, is all the smartest people don't necessarily work for you. And by making your data available to other people who are going to have a different lens, are going to have different techniques, a different goal in mind to analyze your data and try to make sense of it for solving a different problem, they're going to have new insights that you would have never had. And if you can get those, that's where some of those interesting collisions between two people who are looking at the world very differently, being able to compare notes and compare their data, that's where we're gonna see some really interesting solutions come out that we otherwise wouldn't have found.